After you've done some work with tree diagrams, now we got to take a look at another way of representing some probabilities, and these are called area models. So we're going to tackle the same types of problems, but now we can represent them in different ways. So some of these may make a lot more sense to different people. Others people may prefer tree diagrams, but there's another way we can represent probability. We have a carnival game up here, where first I draw a marble from bucket 1. After that, I draw a marble from bucket 2. Question I'm asking is, what's the probability of us getting a green from bucket 1 and a blue from bucket 2? So now we're going to use an area model to see if we can find out how we can solve that probability. Area models work in two different ways. We're essentially making a square, and we're going to have all the outcomes within that square. And so what I always like to think about is we have choice number 1 and choice number 2. Choice number 1, I always draw a big line to represent the side of our square. Event number 1, I draw a vertical line to represent that 1. And now I'm going to split that line up into as many sections, as many choices as I have in that event. So if we look on this picture, I can get a red, I can get a green, or I can get another green. So I have 3 different choices, 3 different options. So I'm going to split this first event into 3 equal parts, because I can equally draw any of those marbles. So I'm just going to split this into 1 section, 2 sections, and now 3 sections. So if I make my big square now I have that original number 1 split into 3 different sections, each now representing a new choice in that game. I have a choice for red, I have a choice for green, I have a choice for green. Now I could say, why do I have 2 greens? Couldn't I just make these combined? Well, they're 2 different marbles, so I do want to split them up into 2 different sections. Now I look at event number 2. Event number 2 is drawing from bucket number 2. And so here I have 4 different choices. So now I'm going to take this other side of my square, this horizontal line, this other axis, I'm going to represent that as my second choice. So now I'm going to split that up to reflect the options in that choice. So now I have 4 options. I can get red, blue, green, or yellow. So now I have 4 choices in that second event, that picking of bucket 2. So I'm going to split this new axis up into 4 sections. Split them in half, and then split each half into half. Now I've split this green line up into 4 equal parts. Combined with this red line, that was 3 equal parts from bucket 1. I'm just going to draw in my marble labels, just so I know exactly what each one represents. So I have a red, a blue, a green, and a yellow. I'm going to get rid of some of this excess information so that does not get in our way anymore. So now I have split up, I have my first choice on this axis, split up into 3 options because I have 1, 2, and 3 choices from bucket 1. Then I have my second choice in green split up into 4 sections, 1, 2, 3, and 4, to represent all those choices from bucket 2. Now if you look, I've made some squares inside this bigger square. And how many squares did I make? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This represents 12 total outcomes. So now there's 12 combinations of the different marbles that will happen if I draw from bucket 1 and then from bucket 2. So now I'm just going to draw in all those possibilities. So I'm just writing out what could happen from that first bucket, and then I'm going to do it in green from what happens from that second bucket. Oops, I screwed up. That has to be a G. So that's what I got in the first bucket, what I could get there. Now if I'm in this area, that means I always drew red first from that first bucket. That's in line with that first outcome over here. This one are always going to be green from that first bucket, because now that's my horizontal green row. And then this one will also always be green, because that was what I chose from that first bucket if those were options. Green and green. Now I'm going to take a look and I'm going to see what would be these vertical things I could add from that second bucket. Well, this first one, I would get a red from this bucket, red and red, blue, blue, and blue, green, green, green. That looks like a 6. And yellow, yellow, yellow. Now I can totally see all the combinations, all the possible marble combinations from bucket 1 and from bucket 2. I go back to my original problem. My original problem is what's the probability of getting a green and a blue. So now I'm just going to count up and kind of highlight all those ones that have a green and a blue. I didn't say order, so I'm going to kind of count in any particular order. So I have this square that gives me a green and a blue. Let's see, nothing else in that row. This one gives me a green and a blue, and nothing else from that row. And looking at this row, I drew a red from that first bucket, so there's no way I can draw green and blue together. So now I have two outcomes that give me green and blue out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12 total combinations. And I can reduce that down from 2/12. I can reduce that down to 1/6 by dividing both by 2. So my probability of getting green and blue is now 1/6. And that's how we can start using area models.